Here is the 2025 Northern Hemisphere Exam 1. So, starting with data analysis as always. Question 1. The table below shows the rainfall in millimetres recorded at a weather station in Melbourne during the month of January for the years 2016 to 2024. The median rainfall is what we're being asked here. So basically we're just counting up the number of years. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 1 is 10, divided by 2 is 5. So we're looking for the 5th highest rainfall there for median. So I'm just going to go and cross off the lowest, then the next, and so on until I get to the 5th one. 4, and so this is the 5th, so 72.3. Now you can put that into your CAS if you want to, but it might be more time consuming to enter the data than to just count up. Okay, passengers on a tram were surveyed for reasons why they travelled by tram. The percentages are shown in the segmented bar chart below. The combined percentage of surveyed passengers for the reason lower cost or no car is closest to. So we need to look at lower cost and no car. All right, so this one looks like we're going to need to read individually. So that's going to be 22 to 48. And then this one looks like it's going to be 68 to 82. Now remember to check your scale. There are 5 lines in there, so each of those are worth 2. So we're going to end up with, and we can just use our CAS here. Okay, so we've got 48 minus 22 is 26, and 82 minus 68, 82 minus 68. So then just 26 plus 14 is going to give us 40. So that's going to be 40%. The investment returns as percentages of 7 superannuation funds for the year 2022 are shown in the table below. The range of the investment returns was, so we're looking for the highest and the lowest, which is this one here. And it's always the highest minus the lowest. And in this case, remember that the lowest is a negative, so we're going to have 2 negatives there. And those 2 negatives are just going to mean that we're going to do 1.7 plus 4.1, which is going to give us 5.8% there as the range. All right, use the following information to answer questions 4 and 5. So we've got a systolic blood pressure of 50 people. For this group of people, the distribution is described as. Now we can see here that we are tapering off to the positive side, which means that that's going to be positively skewed. And the percentage of people with systolic blood pressure less than 120 is closest to. So we're going to find 120, and then we're just going to add up these groups. So we've got 4, 6, 8, 10, and 8. And so we're just going to add those up. 4 plus 6 plus 8 plus 10 plus 8. And now that was out of 50 people. And then to convert to a percentage, we just times by 100. So that's going to give us 72%. Okay. Next, the distribution of weights of eggs produced at a chicken farm is assumed to be normally distributed. So analysis of 2,000 eggs was shown. 16% weigh more than 96 and 97.5 weigh more than 51. So I'm just going to draw my bell curve down here. Okay, so we've obviously got our middle, and then 1 standard deviation below and above, 2 standard deviations below and above, and 3 standard deviations below and above. All right, so what we have here is 16% weigh more than 96. So we know that this is 16% and that is 16%. So 16% weigh more, which means that's going to be 96. And 97.5 weigh more than 51. So that's actually going to be down here. So that's 50%. And then 97.5 is going to be 2.5% below, which is this section. So that means that's going to be 51. Using the 68, 95, 99.7% rule, the mean and standard deviations of these weights are. Okay, so we need to find the mean. So we've got 1, 2, 3 standard deviations between these two bits of data. So we've got 96 minus 51 is going to equal 45, and then we need to divide that by 3. So that means my standard deviation is going to be 15. So automatically I can tell you there's not going to be these 3. So it's definitely going to be D. We're just going to check to make sure that that's right. So 96 minus 15 is indeed 81, therefore that is the correct answer. The price of one share in a particular company is measured on the first trading day of each month. A reciprocal transformation is applied to price, and the equation of the least squares regression line is that on the first day of trading of month 15, the price of one share predicted by the model is closest to. Okay, so we've got to use our solve function for this. So menu 3.1, and we always use solve whenever we're dealing with transformed data. So we know the month, so we're going to start by doing 1 over, I'm just going to call it P equals, and then we put in our equation 13.2 minus 0.74 times, and it was month 15, and then I'm solving for P, so comma P. Okay, and that's going to give me 0.476, which rounds to 0.48. Okay, use the following information to answer questions 8 and 9. So the scatter plot shows test scores and study time, and least squares line has been added. So the slope of the least squares line is closest to. All right, so what we want to do for the slope is we want to sort of find bits where they cross over perfect corners. So this one looks pretty good, and this one looks pretty good. And we're just going to work out how far up we've gone, because remember, slope is rise over run. Now you can use your CAS for this if you want to use FM stats 2-point equation, but it's probably just easier to do this. So my rise is going from 50 to 90, so my rise is 40, and my run, I'm going from 1 to 3.5, so that's a run of 2.5. And so then on my CAS, I just need to do 40 divided by 2.5, and that's going to give me 16 there as my slope. Okay. From the scatter plot, it can be concluded that longer time spent studying causes higher test scores. Now, we never ever use terms like cause, okay? So that's definitely not going to be there. Longer time spent studying is associated with higher test scores. So the longer you study, the higher your test scores, and that one is correct there. Shorter time spent studying associated with higher test scores, that's not correct, and this last one uses the word causes, so it's definitely not that, so it is going to be B there. All right, question 10. A group of people are shown a list of words. They've got proportion and time. Time is going to be my X, proportion is my Y. So the scatter plot of the data is shown below. Now, I'm going to show you 2 ways to do this. So I've already input my data. So what we can do is we can say, well, I want to use a log base 10 is applied to time. Okay, and time is X. So that means we're going to do here, I'm just going to call it LT for log T. And that's going to be log 10 of time. And I called it time, so I'm going to type in time. Okay, and then we just do menu 414. Okay, X list is my transformed variable. Y list is my proportion. And that gives me A and B. So I'm going to look at A being 0.85 because a 6 makes it rounds up, and B as negative 0.18. So 0.85 and negative 0.18. So it's going to be D there. But if you're not sure on that process, what we can actually do, and I'm going to show you, like I said, I'm going to show you another way to do it. I just might lose the data there, that's okay. So just up here, I'm going to change that to be called X. and that to be called y. And then in our calculator, we can use FM stats. So FM stats, it is transformations. Okay, and we're going to select a transformation because we already know what one we're going to do, and it is log of x, so that is number 3. Okay, and then we're just going to check it. So it's, So it is negative 0.18. Remember that with FM stats, it's in mx plus c form, so that is before the log 10 of x, and then plus 0.85, so we know that that's correct there. Okay, the graph below shows the parallel box plots for average heights of adult males in centimeters for 208 countries. Which one of the following statements can be concluded from the box plot? So the range of the average heights for males is greater in 1946 than 1996. So we're looking at range. So the range there is about 5, 10, 15, about 18. And the range for 1996 is 5, 10, 15, 20, about 23. So is the range higher in 1946? No, it's not. It's lower. So it's not A. The average adult male height was greater than 170 centimeters in 1996 for more than 100 of the countries observed. Now, 100 is going to be a really funny number because it's not quite half, so we can't really guarantee this in a lot of cases. But we'll have a look looking at 1996, and we've got the average height of 170 something. So the average height was greater than 170. I mean, for more than 100 countries, I mean, technically it could be, but it possibly is not definite, so we can just leave that one as a question mark and check the other one. So we'd really have to see if the other ones are incorrect in order to see if that one was going to be correct. The largest average male height observed in 1896, was less than the median average of male's height in 1996. So the largest male, so that's my maximum, was less than the median average, so less than the median, and we can see that that is actually not true. The median there is actually lower than the largest here, so C is definitely not correct. And no countries out of any of the 208 countries observed had an average adult male height less than 155. And we can see that that is not correct either because that value there is less than 155. So B then is definitely the correct one there. Now, the only reason we can't say for definite is we can obviously see that 170 is below the median, but that here just indicates that it's going to be 25%, and we don't know whether the 25% are spread close to the median or a bit further away from the median. So we really kind of do have to make sure that we're really careful with the language there. Okay, the least squares line of this is fitted to the explanatory variable and response variable. The standard deviation of the response variable, of the explanatory variable, is twice that of the response variable. So I'm just going to start writing things down, Sx and x, y. So the standard deviation of the explanatory variable is twice that of the response variable. All right, so if the response is 1, the explanatory would be 2. 81% of the variation in the response variable can be explained by the variation in explanatory. So 81%, that means 0.81 is r squared. And the correlation between x and y is negative. So that just means my r value, which is going to be negative 0.9, because 0.9 or 9 squared is 81. And the residual associated with the data point 25 is 0.5. Okay, so one thing that we need to know here is that the slope B is given by r sy over sx. Okay, and that's just from our least squares regression line formula. So I can calculate I can calculate my slope. So let's say that we've got negative 0.9 times 1 over 2, which is going to give me negative 0.45, because that just means half of negative 0.9, which is negative 0.45. So that's my slope. Okay, now what I do know, I'm just going to rub these out so that I can, I'll rub these out so that I've got a little bit more space. Oh, gosh. Okay. All right, so what I do know is that when I do my residual, I know that A minus 0.45 times 2 is going to give me a residual of 0.5. Now remember, residual is actual minus predicted, which means that my actual is 5, my predicted must be 4.5. So that must equal 4.5. Okay, so I can actually use my calculator to then figure out the value of A. Okay, so menu 3(1) for solve. So 4.5 equals A minus 0.45 times 2, because 2 is my X value, comma A, close brackets. That's going to give me A as 5.4. Okay, so that means now I can find the residual for this value because I have an equation. So 5.4 minus 0.45 times 3 is going to give me 5.4 minus 0.45 times 3 is going to give me 4.05. Okay, and now we find our residual by using the actual minus the predicted. So the actual is 4 minus 4.05, so that's going to give me negative 0.05. Right, so a little bit of working out there is required to get this question, but the main important thing is that we're recognizing that because we're getting given the standard deviations, we have to use that formula, and then knowing that that's r squared, or this is r squared and not r, and then knowing how to find A using the residual values. So a bit going on there. All right, question 13. A time series plot shows the price of gold for 10 days. When smooth using 3 median smoothing, the time series plot will look like this. All right, so this one here is going to be 1, 2, 3, and the middle one's going to be there. Okay, the next one, the middle one's going to be here. So what I'm looking for is I'm looking for it to go up initially. So B is definitely not going to be correct, but the others potentially could be because they go up. And then we've got this one, and this one. So then I'm going down, but I'm actually going to go down to exactly where I was in the first place. So it's going to go up and then down to back where it was. So this one's not right then, and that one's not right either. So then it definitely has to be D. Okay, because it's got to go in like a triangle, and these ones don't make an even triangle or an isosceles triangle. Okay, use the following information to answer questions 14 and 15. So seasonal indices. Now, we're missing a seasonal index, so we'll get to that in a minute, but the seasonal index for summer is 0.75. So this tells us that on average, the number of umbrellas sold in summer is, now 0.75 means we're less, so we're 25% less than the seasonal average. Now, we know that the seasonal indices always have to add up to the number of seasons. So we're looking for the deseasonalized value of the number of umbrellas sold in autumn, so I have to actually calculate that. So we're going to do 4 minus, and then each of the seasonal indices, 0.75, 1.28, and 1.1. So that's going to give me 0.87 as my autumn seasonal index, 0.87. Okay, now we want the deseasonalized value of umbrellas sold. So I've got my seasonal value or my actual value. So I can use FM stats for this bit. So into the book, FM stats, and down to seasonal. Okay, so I know that I'm looking for a deseasonalized value. So number 1, my actual figure is 9469. My seasonal indice is 0.87, and that gives me 10,880. Okay, just note that I have actually put the wrong value in here. I put 66 instead of 69, and that was just my fingers pushing the wrong button. So it is going to be D, but we're just going to check to confirm that that is completely correct. Okay, so 1, and then 9, 4, 6, 9. There we go, and 0.87. Okay, so we can now see that that is 883.9. Okay. So question 16, consider the following 4 statements of this time series plot. Seasonality is present, so let's have a look. We've got 6, 18 is pretty low, 30 is pretty low. So we see that all these values that are low, they're all within 12 months. Okay, so seasonality, yes. An increasing trend is present. Yes, because it's going up in general. Irregular fluctuations are present. Yes, because that always happens in every time series plot. And a structural change is present. Now remember, a structural change is something that looks like that. So a structural change is not present here. So it's just 1, 2, and 3 only. All right, recursion and financial modeling. So seeing some numbers to generate this, the first negative term in the sequence is, all right, so I'm just going to set this up. So I'm just going to go 30, enter, and then times 0.5 minus 5. So that's going to be term 1, 2, 3. So term 3 is going to be my first negative term there. Okay. Roderick receives a monthly payment after investing $440,000 in a perpetuity at an interest rate of 5% per annum, compounding monthly. The monthly payment provided in its second year, well, it's the first year, second year, all the payments are the same, so it doesn't actually matter. Menu 8.1. So perpetuity, we always use N as 1, interest rates 5. How much did we borrow? We borrowed 440,000. Well, we actually invested it, but it doesn't matter. We're looking for payment, and that one has to be the same value, but in the negative form. And then we're looking monthly, so we've got to change that to 12. Okay, back down to payment, and we will see that our payment is $1,833. Okay. Aisha took out a reducing balance loan of $500,000 with interest calculated quarterly. The balance of the loan in dollars after n quarters can be modeled by this. With regular quarterly payments, Aisha will repay the loan in 20 years, the value of D. So D is our PMT. Okay, so again, we just have to put these values into Finance Solver. So we're 20 years quarterly, so 20 times 4. My interest rate, we've got to actually calculate my interest rate, but it's 0.015 times 4. Okay, so all I've done there is I've just taken away the 1 and then I've multiplied it by 4. And then I have to multiply it by 100. Whoopsies. Okay, now I borrowed 500,000. I'm looking for my payment, and at the end of the loan, it's going to be 0. Don't forget to change PPY to 4, and then find the payment. So the payment is $10,774.16. So that's going to be C there. Okay, question 20. Teresa has office equipment that she purchased for $8,000. It depreciates using reducing balance method. After 4 years, the office equipment is valued at $3,000. The annual reducing balance rate for Teresa is closest to. All right, now we know that it's going to get to 3,000, which is R to the power of 4 times 8,000. Okay, and I'm just going to put that into the CAS. Menu 3.1, 3,000 equals R to the power of 4 times 8,000, comma R. Okay, and now R is my growth factor, so I'm just going to copy that value. I'm just going to do 1 minus. Control V, and then that gives me 21.7%. Okay, so C there. It's going to be the right answer. Okay, Nina invests $2,000 at 9.25% compounding annually. How many years will Nina's investment first be more than double its initial value? So And this means that I need to find out how long it's going to be to get to 4,000. So 4,000 is going to equal, now that's 1.0925 to the power of n times 2,000. Now, you can do this in multiple different ways. You could just do this till it gets to 2, but I prefer this way. Menu 3, 1, 4,000 equals 1.0925 to the power of n times 2,000, comma n. And that's going to give me 7.8, which means it's going to double in 8 years. Okay, because at 7 years, you're not actually, I mean, it's not an option anyway, but at 7 years, you haven't reached double, so you've got to wait to the 8th year. All right, recursive calculations to determine Vn in dollars of reducing balance loan up to n time are as shown. All repayments are made the same until the final one. The interest rate charged on the loan does not change. To ensure the loan is fully repaid to the nearest cent the last payment could be. All right, so this is a final payment question. But it's a final payment question when we don't actually know n. So I have to actually calculate n first. So this is definitely a finance question. I don't know n. I do know that my interest rate is 0.003 times. Now, do we know what? We don't even know what our time period is. Now, I'm just going to make an educated guess here and say 12. So I'm going to say it's monthly. Okay, and monthly gives me an interest rate at 3.6. So that makes sense. Okay, anything like higher is probably going to be too high. Anything lower is going to be too low. So we'll just go with that. We borrowed 400,000. We know our payments are 2076.19. Oh, and that needs a negative sign there. We know we're going to get to 0 because we want to know how long it's going to pay off. And we said that our compounding period was 12. So how long is n going to be? Okay, so this is a really good indication that we were correct with our 12 because that is very, very close to 288. So 288 is going to be my time period there. So now all I need to do is calculate what my future value will be. So this means that I am 15 cents still owing at the end. So I'm just going to add 15 cents onto my 19. And if I add 15 cents there, it's going to be 34 cents. So 2076.34. All right, Yanni took out a loan of $10,000. Yanni makes no repayments in the first year. Compound interest is a fixed rate per annum, though the compounding period may vary. If the interest compounded monthly, then the effective interest for this loan would be 6.4% per annum. If the interest compounded annually, the amount of interest charged in the first year would be closest to. All right, so this is the effective interest rate. So I actually have to reverse that by finding my nominal rate. All right, so I'm going to use my CAS and I'm just going to type in NOM. Okay, NOM is going to give me my nominal. NOM. Open brackets. I'm going to have 6.4 comma 12 because that's what it was when it was monthly. Okay, so that gives me an interest rate of 6.2196. So 6.2196. Okay, now I borrowed $10,000. So let's just say that I'm doing this for $10,000. Now I'm compounding annually, which means I now don't have to do anything with that. All I'm going to do is take this value, divide it by 100, and then times it by 10,000. Okay, so we've got $621.96 or $622. And lastly, Kenneth borrows $165,000. He is charged interest at 6% per annum compounded quarterly. Scheduled repayments are that per quarter. Halfway through the term of the loan, Kevin pays off the entire remaining balance in one payment. The amount Kenneth saves in interest by doing this is closest to. Now we've got a halfway through, but again, we don't have n, so we have to find n first. So let's figure out what n is. So menu 8.1, we don't know n, we do know an interest rate, we do know how much he borrowed, we do know a payment. We do know that that's going to disappear, and we do know that that's going to be quarterly. Okay, so our n value is going to be, all right, so 40 payments is the n value. All right, so what we actually want to find though is half of that. So we actually want to find what happens at 20 payments. And at 20 payments, he still owes this much money. So a few things going on here. Control C. So he's got 9,712. That's how much he's got remaining. But what he's done, so that's what he's done, he's actually paying this much money. He's actually doing that 20 times, and then he's paying that off. Okay, oh, that's a 2. Yeah. Okay, so this is what he's actually paying. So 5515.47 times 20 plus 94700.12. So that means he's actually paid that much money. And then we take away the amount he initially had. So he's got an interest of that much. Okay, so that's how much interest he's actually paid here. So 40009.52. Okay, alternatively, he would have paid 5515.47 times 40. So he would have done that 40 times. So 5515.47 times 40 is going to give 2206. I don't really need to write that. I can just then take away the 165,000 that he borrowed. So 55,618, 55,618.80. Now, just a bit note that that doesn't include a final payment, but these values are all quite different. So it'll be fairly easy now to see which one it's going to be. And if we do our long one, if we did the whole time, take away our initial one. I think I made a little mistake here. Then we will get B as our answer. Now, just note that that is actually going to give us quite a different answer. It's actually going to give us like 609, which is not that close to here, which probably means that I've made a small mistake. So I'm just going to go back and check my finance solver. Again, in the long run, it's not really going to change much of what we have. I'll see. So can you see what I've done here? I actually did this as 17 and not 47. Okay, so let's see how much that changes it. Yeah, so it changes it a bit. It's 94693. So that becomes 94693. I'm just going to check to make sure if that's going to get me closer to an actual answer. 69318. So I'm just going to go up here and change that to 9469318, which gives me that minus 165,000. Yes, that's going to obviously look a lot better. So if we do that now minus that. Yeah, so now I get basically smack bang on that answer. So the answers, even though they say closest to, the answers are usually always like it's rounding. That's the closest to. So as long as you pick the nearest whole number, it's fine. So if you're out by more than like $1, you've probably made a mistake. Now, again, in this case, it didn't make that much of a difference, but obviously in a short answer paper, this would have made a significant difference. All right, matrices. The matrix shown is symmetric. Remember, symmetric means that the rows are the same as the columns. So the values of A, B, and C are. So this needs to go 0, 1, 7, 3. So this is 0, 1, 7, 3. So A is 7. So D we can cancel out. The next one, we've got 1, 0, 2, 8. So down needs to be 1, 0, 2, 8. So B is 2 and C is 8. Okay, so A there is the correct answer. All right, matrix K is a square matrix. Multiplying K by its inverse will result in an identity matrix. And that is just a knowledge thing. We just have to know that K times K inverse is the identity matrix. And that's because like 2 times a half is 1. And the identity matrix is the same as 1. Okay. The following life cycle transition diagram shows the life cycle of female population of a certain size. Compared with its initial size, in the long term, the female population is expected to. All right, so for here, I'm just going to have to put it in because, I mean, we can see that we're obviously going to get lower here and we're not really building that many in our moving up. So it's likely that it's going to decrease, but the best way to do it is just to check. So all your birth rates go along the top and then all of your survival rates go along the diagonal. Okay, 0, 0, 0, 0, 0, 0, 0, 0, 0. And all I'm going to do is I'm just going to multiply it by 100 in each. Whoop, that's 1,000, but we can just do it by 1,000, no problem. Okay, because all I'm doing is I'm just going to check to see what's going to happen to my population. Okay, so put it in my matrix and it's a 4 by 4 and it's 0, 0.5, 0, 0, 1.2. I'm just going to go across actually. 1.1, 0.7, that's a 0. That's a 0. That's a 0. That is a 0.6, 0, 0, 0, 0.3, 0. And we're just going to multiply it by another matrix, this time a 4 by 1, and 1,000. Okay, so we want to see if it's how much is going to go up by or down by, or if it's going to stay the same. So we can see here that if we add these together, we have 3,500, 4,100, 4,300. So it's initially going to go up, but this one actually asks us for the long term, which means I really need to multiply this by a large number. And I'm just going to choose 100. That's just my go-to long-term one. All right, so we can see here that this is significantly different. So we've got 1,500 and 30. And I'm just going to round because there's no reason why I don't have to. 767 or 768, but again, it's not going to matter because I'm just seeing what's going to happen with the population. Oh. +1, 3, 8. And you can see that that's actually significantly lower. So over time, the population is going to decrease. So we started with 4,000, we only had 2,800. So that is a decrease there. Okay, use the following information for questions 28 and 29. A shop sells mattresses. The mattresses come in 4 sizes. The mattresses come in 2 comfort levels. And it shows the type of mattress. So mattress C gives the predicted number of each type of mattress that will be sold during February 2026. So we've got lush, firm, and then the different sizes along the top. So matrix C could have been calculated using which of the following equations? All right, so we can see that we are changing our numbers here. Now we just want to look at how much it's going up by. So 45 to get to 60 is actually increasing by 15. So we're going to do 15 over 45. We're going to see that that's actually the same as a third. Okay, but what is actually happening is it's increasing by a third, which means it's a third plus 1. So it's actually going to be 4 over 3 times C or B. Okay, so it's actually going to be D there because it is increasing. So automatically we can say no to A and B because they're both going to go lower. because their numbers are less than 1. All right, so make the matrix product x c minus b to the power of t, which the t means transpose. Oh, goodness, sorry. It means transpose. With the total predicted increases in sales for both Lush and Firm between February 2025 and February 2026. All right, so we've got C minus B, which is just going to give us a 2x4 matrix. And then we're going to transpose that, which means our rows are going to become our columns. So it just means that that's now going to be a 4x2. So I want to get a row matrix, and we know row matrices are always going to be 1 by something, which means my first one here, in order to make that a 1 by 2, must be a 1 by, and then to make a multiply, it has to be a 4. So we're looking for a 1 by 4, which is going to be C. Okay, so Ben is writing a multiple choice test for his class. For each test, he has 5 multiple choice questions. Test 1 have the following answers. We're doing a permutation matrix to decide for test 2 onwards according to the rule. Okay, so what this is showing us is that he noticed that the answers in 1 and 4 never change, which means they must be on the diagonal. Okay, so then 0, 0, 0, 0, and then 0, 0, 4, 0. But the other ones do change, which means they cannot be on the diagonal, which means these diagonal ones are going to be zeros. All right, now it doesn't actually matter where the other ones go. They just have to be in a position where they will change. So I'm just going to go, say, that has to be 0. These all have to be zeros. It's going to be, say, 1 here. Say 1 here. And then this one can be a 1 there. Okay. So what we want to do is we want to actually make it so that once we multiply this, or once we raise it to a power, it's going to give us the same thing. And in order to give us the same thing, the answer must be the identity matrix. So we're going to work out how many times we have to multiply that by to get the identity matrix. Now, only the order of 2 of them actually matter, and the rest of it doesn't. So it doesn't matter if what I put in my calculator doesn't actually match what I wrote on the screen, as long as the 2 that are important are going to be the same. So this has to be 0 and 0. Let's just make that 1. 0, 0. Make that a 0, 0, 0, 0. Now, when you're putting all the other numbers in, it's just really, really important that we don't have anything on the diagonal. So, for example, if we'd left this one where the 1 had to be at the very end, then we would have to change it because we can't have the 1 on the leading diagonal, but this one's fine. All right, so I'm going to raise this 2 powers, and as I do it, I want to see when my identity matrix comes up, because the identity matrix is the same as multiplying it by, is the same as multiplying it by 1. So my identity matrix has come up with my power of 3. But it is really, really important to note that this is actually, and I'll just get rid of this so we can see it properly, this is actually n minus 1. So if n minus 1 is 3, that's a plus. If n minus 1 is 3, then that means n must be 4, which means it must be test number 4. Use the following information to answer questions 31 and 32. A course requires students to pass 2 levels of study before they graduate. Each level of study takes 1 year. Students must pass the first level before they move to the second level. Students must pass the second level before they become graduates. And from 1 year to the next, it is known that 80% of students pass the first level to progress to the second level of study. I'm just going to start by trying to put this in my matrix. Level 1, level 2. I'm just going to say graduates there. level 1, level 2 graduates. Because you've got to get from level 1 to level 2 and then graduate. So 80% of students move from level 1 to level 2, which means 20% don't, but you also can't go from level 1 to graduate. So graduates is going to be 0. Okay, now 60% of students in the second level become graduates. So second level to graduates is 60%, so 0.6. Students who do not pass a level of study repeat it the following year. No student leaves the course before graduating. Okay, so 60% of students do that. That means 40% stay in level 2 and 0 because you don't go backwards. And if you graduate, you stay graduating. So the thing is here is that it looks like this is probably going to be a 2x2 matrix, but it's actually a 3x3 matrix. What percentage of students are expected to graduate without repeating a level? So I'm just going to use this as a percentage. I'm going to say 100% start at level 1. So let's see, when is the first time you're going to graduate is going to be year 3. Okay, so we're going to do 1 multiplication is going to give us year 1. And then, so raising it to the power of 2 is going to give us the year that they can graduate. So putting it in CAS. All right, 3x3. We've got 0.2, 0.8, 0, 0, 0.4, 0.6, and 1, 0, 0. I'm going to raise that to the power of 2. Then I'm going to times it by a 3x1. I'm going to start with 100 because we can just use that as a percentage, and then 0, 0. So it looks like we've got 48 people that graduate for the first time that you would have graduates. And I'm just going to show you that if we actually did this as just a power of 1, we should get 0 people in the graduating position. Yeah, so 48 there is the answer. Okay. At the start of 2025, the number of students enrolled in L1 and L2 of the course who have graduated from the course are given by the recurrence relation. T is the transition matrix showing the expected proportion of students moving from L1 to L2 to G 1 year to the next. SN is a state matrix n years after the start of 2025. To ensure that there is always students studying the new course, new students are enrolled in the first level every year so that the number of students studying the course remains at 1,000. Okay, so we can actually already kind of use what we've got. So K is the number of new students enrolled in the first year level. What year will, at the start of which year will the expected number of students who have graduated from the course exceed 5,000? Okay, so I'm just going to take this one and I'm just going to change that to 1,000. Now we're also going to figure out, all right, so here we can see that after the first year, 200 people have to repeat, which means that in order to keep it as 1,000, I'm going to have to make my K value 800 because I want to keep that at 1,000. So K is going to be 800. All right, now we have to set this up in our calculator properly. So I'm going to remove my transition matrix and I'm going to just push enter there. Then I'm going to get my transition matrix back. Remember, we're going to do this as control answer plus, and then we're going to do 3x1, and then that's going to be 800, 0, 0. I'm just going to check it. Oh, dimension error. Oh, because I did times, not plus. Whoopsies. And now this won't work because it's not going to be set in the right thing. Yeah. Damn it. All right, that's okay. We can just come and grab this one. And then grab this one again. Okay, control answer. All right, so first year, and we got 1,000, so perfect. Second year, still 1,000, great. Now I'm looking for when people graduate, so I'm just gonna, I've got to count them. But I'm looking at till the graduates first exceed 50,000. So that's 1 year. 2, 3, 4, 5, 6, 7, 8. So it's 8 years, but it's 8 years from the start of 2025. So that makes it 2023. Sorry, 2033. All right, networks and decision maths. 4 workers at a factory allocated 5 tasks, all of which must be completed. Each worker must complete at least 1 task, and 1 worker must complete 2 tasks. The bipartite graph shows the tasks which can be completed by each worker. The worker who must complete 2 tasks is, well, it's going to be this one because they've only got 2 possible people, so it's going to be Leslie. All right, a planar graph has 9 edges and 6 faces. The number of vertices is, so we've got V plus F equals E plus 2. So we've got 9 plus 2 is V plus 6. So we've got 11 equals V plus 6. So the number of vertices is 5. Okay, so consider the graphs below. Which 2 graphs are equivalent? All right, so we're just looking at which ones match. So it's definitely not 1 and 2. So A goes to B and D and C. So A goes to B and D and C. A goes to B and D and C. All right, so that didn't help us. Now B goes to A and D. B goes to A and D. Yep. B goes, nope, so not that one. And then we just check. C goes to A and D. C goes to A and D. And then D goes to B and A and C. Yeah. So it's 1 and 3 there are the ones that match. Okay, consider the weighted graph below. Which of the following is not a minimum spanning tree? All right, now just looking at this, I can't tell because there's no like loops or anything. So that's what we're looking for mostly. So what we need to do is we need to start at the lowest possible value, and they're all 9s and 10s. So we just pick anywhere. So I'm just going to pick this one and then this one. Okay, and then this one and then this one and then that one. All right, so that's got all my 9s. So is there any that we can cut out so far? Yes, it's not going to be C. Yeah, so that's the only one we can cut out so far. All right, then I just have to I can actually go up here as well. But again, that doesn't help me. That's also a 9. So then all I have to do is I just have to connect to S and T. Oh, which is not a minimum spanning tree. Oh, it's just going to be C. Okay, not a minimum spanning tree. C. Okay, great. Okay, the adjacency matrix shows all the roads connecting these 5 towns. The road connections could be represented using which of the following? All right, so I don't really like these questions, but we got to do it really methodically. So V goes to W in 3 different ways. So V well, it's definitely not A because I can't get B to W in 3 different ways. 1, 2, 3. So it could be C. 1, 2, 3, 4. So it can't be B. And 1, 2, 3. Okay, so we're down to 2. And again, pencil's really, really good for networks. I'm just going to rub it out so that I know that that's correct there. Okay, so, and then V also has to go to X. Oh, which it can't do. So it has to be D. Because then V can go to X that way. Great. Wasn't too painful. All right, question 38. 3 friends, Alex, Vishnu, and Cassie start at a station and travel through the city, ending at town hall. The following network shows the distances of the streets they will travel. The vertices represent city landmarks from station. Alex will travel towards vertex A. Vishnu will travel towards vertex B, and Cassie will travel towards vertex C. All 3 journeys end at town hall. Which of the following statements is not true? All right. Only Alex could have the shortest distance. Only Vishnu could have the shortest distance. All right, so basically we just have to figure out the distances. So Alex is going to travel towards vertex A. So he's going to do this one. Now he can go there and there. And then he can do these 2, but they're actually going to be exactly the same distance because they're both going to be 340. So Alex's distance is going to be 150 plus 140 plus 160 plus 180. So Alex's distance is going to be 630. Okay, it's going to change color. All right, Bishnu travels towards vertex B. So he's going to go this way and then work out how he's going to get through. So we've got 30 and 110 is 240, 340, and that's going to be 350. So this one actually is going to be shorter. And then that's only 210 as opposed to 220. So that way is going to be shorter. So his shortest distance is going to be 170 plus 130 plus 110 plus 100 plus 110. So his is 620. Did I mess up Alex's? 150, 140, 160, 180. I did mess up Alex's because I don't know if you guys picked up on it, but if Alex goes this way, he's going to also follow that same path there, which is actually going to be 10 shorter. So Alex could also be 620. Okay. And lastly, Cassie will travel towards vertex C. So she's going to go this way, and then we're just going to figure out which way is shorter for her. So she's got 160 and 190 or 180, 180. Now this way is definitely going to be shorter than doing that way. And 160 and 190 is going to give us 350, whereas 180 and 180 is 360. So that way is shorter. So she's got 170 plus 160 plus 190 plus 110. So she's got 630, which means that the correct answer here is that Alex and Bishnu could have the shortest distance, but not Cassie. Okay? Because even Cassie's shortest distance is still 630. Alrighty, question 39. The following network represents the flow of water from an easement into a stormwater drain. The water flows through pipes. The number of represents the pipes, the water through pipes in liters per second. To increase the flow of water from the easement to the drain, the direction of flow of one of the pipes can be reversed. To achieve the maximum increase, the direction of water should be reversed between which two vertices. All right, so basically we're just dealing with cuts here. So that's going to be my first cut. That's going to be 50. This one is definitely a lot shorter. That one's going to be 35. But again, nothing there's backwards, so that doesn't really help us. All right, that way is not backwards, but this way will be backwards because we're going this side to that side. So this is going to be 12 and 14, so that's only 26. This one gives us 36. This one gives us 25 and 18 is 43. Well, that's really high, so that 18 is probably not really going to make a difference. And then that's high one anyway, with nothing backwards. And then that's also pretty high. I'm just going to switch colors just for a sec. And if I go this way, I'm still high. So really what I'm looking at is my lowest option. And my lowest option here is going to be my 26 cut. Where is my 26 cut? Yeah, so that's that way. That's backwards, that's backwards. Yeah, so that's my 26 cut. So it really needs to change the 26 cut. Now, if I look at B to F, that will increase that one, but that will increase 26 to 40, but it doesn't actually increase this one at all. Whereas if I change B to G, then that one is actually going to become, so that's currently 30. That's currently 30. So then that will actually change that to 43, and that will change this one to 39. So I'm going to say it's BG. CI is already on really high cuts anyway, and HI, again, it's already on like around really high numbers, so that's not going to make a difference there. So we're going to say it's BG. Okay, so we're really looking for here the lowest cut and the one, like changing one that affects both of those. And BF only affects one, but the BG affects both the 26 and the 30 cut. Last question. A project involves 11 activities, A to K. The duration in days immediate predecessors are given below. When the project takes place, the duration of activity F is increased by 4 days. By how many days does this increase the original completion time of the project? All right, so realistically, we're going to have to draw it because there's not really an easy way to do this without really being able to visualize it. So I'm just going to draw it. So we've got A, which is 7, B, which is 9. Coming off A, I've got C, which is 13. Coming off B, I've got D. I've got D, which is going to connect up with C. And D is 6. Okay, also coming off B, I have F, which is 16. And I have G, which is 7. Now, I've got, coming off G, I've got H, which is 5. Coming off H, I've got I, and then I've got all these ones. So E, F, and I have to all connect up. So E comes off C and D. So that means F needs to connect to that. That's E, which is 8. And then I needs to connect to here. So that's I, which is 5. And then K comes off H as well. And then J is that one. J, which is 9. K comes off H, which is 12. Okay. So that's my drawing. Now, you will probably have to draw them more than once, or like draw it out and then like rub it out. So again, pencil's really, really important here. Alrighty. Now, I'm going to put my boxes in. And again, I recommend that you do your boxes in pen so that you can rub them out if you make a mistake. So you can do like fill your boxes in with pencil, but you can like rub the pencil out easily. Okay, now this is a really good thing to look at in reading time, whether you need to know that you've got a lot of time left at the end of the paper in order to like fill this stuff in. Okay, so we've got 0, 0, 7, 9, 9, 9. 7 and 13 is 20. That's going to be 20. 9 and 7 is 16. 16 and 5 is 21 and 21. Then we've got, that's going to be 25. So J has to be 28 because 25 is not as much there. And then that's 9. So then that's going to be 37. And that's going to be 33. So 37 is correct there. Okay, now F. So when the project takes place, the duration of activity F increases by 4 days. So F is now actually going to be 20. And again, I'm going to change color here. So F is now going to be 20. So that means that this actually isn't going to be able to start till 29, which means that that's not going to finish until 38. So all it does is it just increases it by 1 day. Okay, now if you did the whole thing and we worked backwards, we would say, well, that's going to be, oh my gosh, 25. That's going to be 28. 28 minus 5 is 23. 23 minus 5 is 18. It's going to be 11. And then 28 minus 16 is going to be 12. So we can see that that has a float time of 3, which means that if you increase it by 1, it's just going to increase the whole thing by, increase it by 4, sorry, it's just going to increase the whole thing by 1 day because the float is 3 already. And that is done. Thanks for listening. All right.